One moment the Earth was ruled by giants, the next it was nearly silent. A massive asteroid had slammed into the planet. The impact triggered tsunamis, firestorms, and a shroud of global darkness. Within hours, ecosystems collapsed. Species that had ruled for millions of years were gone in a flash. On today's episode of the Infographic Show, we're walking through what actually happened on the day the dinosaurs died. Around 66 million years ago, high above what is now the Yucatan Peninsula in modern-day Mexico, an enormous chunk of space rock was hurtling through space, and it was on a collision course with the Earth. Traveling at over 45,000 miles per hour, this was no ordinary space pebble. It was roughly 6 miles wide, and it packed a destructive force unlike anything humanity has ever witnessed. This impact would unleash the energy of 100 trillion tons of dynamite, the equivalent of 100 million megatons. For context, most nuclear bombs measure in the single-digit megatons. This rock carried the punch of several billion nukes. And the dinosaurs had not evolved with the natural ability to duck and cover. Several minutes before impact, after a 60-hour journey through space, the asteroid reached the Earth. Blazing brighter than the sun, it streaked toward the Yucatan Peninsula, visible for only a few brief seconds. Then a blinding flash lit up the sky. The air in front of the asteroid would have been compressed and violently superheated thanks to its speed. The heat would have allowed it to blast a hole directly through the Earth's atmosphere, triggering a supersonic shockwave, and that was before it had even hit. An instant later, though, the rock from outer space would come slamming into the Earth at a spot just off the coast, striking in the shallow part of the seas of the Gulf of America, formerly known as the Gulf of Mexico. Moment of impact. The asteroid slammed into the Earth with apocalyptic force. Think about it like this. The little boy nuclear bomb that landed on Hiroshima had an explosive yield of just 15 kilotons, 15,000 tons of TNT. That blast and subsequent fallout killed nearly 250,000 people. The asteroid? No humans were around to witness it, but its impact unleashed a blast of more than 6,600 times that size. Bigger and badder, and only the beginning. The sheer force of the impact sends the rock burrowing deep into the Earth's crust, leaving a huge crater in its wake that is almost 120 miles wide and 19 miles deep. Today, the impact site is known as the Chicxulub crater. Its center is buried offshore underneath the nearby Mexican peninsula. As the asteroid hit the ocean and the bedrock below, all of that energy, the hundreds of millions of megatons, would almost be instantaneously released as the lump of space rock itself was vaporized, along with anything standing too close by. Within seconds, everything nearby, from living organisms to thousands of cubic miles of rock, would have been boiled into nothing. Thanks to the sudden release of the thermal radiation, any prehistoric creature who witnessed the asteroid's impact would have been incinerated in an instant. That radiation would travel at the speed of light, burning anything and everything within a radius of just short of 1,000 miles. That means that any trees and other flora in the immediate vicinity of the blast would catch alight and be burned into a cinder in seconds. Even the bedrock underneath the impact site of the asteroid would start to melt thanks to the intense heat of the explosion, becoming a scorching mass of burning rocks. With the impact driving the asteroid into the Earth's crust, it would have the same effect as dropping a stone in a puddle, pushing the waters of the Gulf of America back in all directions. Simultaneously, superheated rock was blasted upward, forming a temporary mountain that rose miles into the sky. The force was so immense that ash, molten debris, and shattered crust were hurled into the atmosphere. Some flung so high they escaped Earth's gravity and shot off into space. As for where the rest of it went, well, stick around, because that much debris doesn't just vanish. In short, the instant the asteroid struck, all hell would have broken loose. Minutes after impact. It wasn't just the dinosaurs standing nearby who were affected by the blast. The impact had set off a chain reaction that would lead to a mass extinction event. In the coastal regions, the asteroid's impact caused severe tsunamis, especially when that temporary mountain came crashing back down, displacing the water below. Waves as tall as 1,000 feet surged forward from the oceans and washed away huge chunks of landmass, drowning the coasts of most continents. In addition, creatures who weren't directly near the impact site would have felt the impact. The moment the asteroid struck, it triggered a magnitude 11 earthquake, a force so extreme no human in history has ever experienced anything like it. Even the creatures alive at the time had never felt a quake that violent. The ground didn't just tremble, it roared. Shockwaves raced through the planet, shaking the Earth so hard that tremors would have been felt on the opposite side of the globe. There was literally no way to escape. Several shockwaves would have erupted too thanks to the asteroid, many strong enough to flatten entire forests for thousands of miles around. The explosion would have sent an initial shockwave erupting outward, traveling at speeds of more than 600 miles per hour. On the nearby land masses, in places that would one day be Middle America, vegetation would have been obliterated by the force of the shockwaves, with any unlucky dinos wandering around flung miles away. If the shockwave didn't kill them immediately, then the subsequent flight and fall surely would. And then there is tons of molten rock that soon came raining down from the sky. 15 hours after impact. Most of the bigger waves caused by the asteroid would have been refracted around South Africa, though many would still manage to be over 300 feet tall. And as if all that wasn't hellish enough, remember all that excess material sent up into the atmosphere? Well, it wouldn't be staying up there for very long. While some of the Earth's destroyed crust and fragments of the initial meteor would have traveled further out into space, some striking the Moon and Mars, a lot more of it came raining right back down onto Earth. Much like the asteroid, as millions of tons of debris came speeding through the atmosphere, it would have been rapidly heated. The thing is, there was so much debris and molten rock thrown into the air that it didn't just darken the skies, it heated them. Scientists still debate how bad it got. Some say the atmosphere reached temperatures into the hundreds of degrees for several minutes. Others believed it spiked into the thousands, turning the sky into a global oven for a brief but deadly instant. Either way, survival on the surface was impossible. Those that couldn't make their way below ground would have been roasted in the intense heat. Any creatures still out in the open wouldn't just face this heat, they would be pelted by superheated debris raining down from above. The scorching atmosphere, combined with tons of molten rock falling back into the earth, would have ignited massive forest fires almost instantly. Vegetation would have gone up in flames within seconds. These fires likely spread across entire continents, burning relentlessly for months and wiping out vast swaths of plant life. Impact Day itself was an apocalypse, one that ended the dinosaurs' reign, which had lasted almost 165 million years. The moment the asteroid hit, a considerable number of dinosaurs, even entire species, were wiped out. The impact marked an end to both the Cretaceous period and the Mesozoic era, and kicked off the Cenozoic era, the Earth's current geological era. Subsequently, the Paleogene period began, though if you thought that was the end of the story, it most certainly wasn't. You see, we often like to focus on that cataclysmic impact and assume its effects were felt simultaneously and instantly, killing every creature on the globe, because that is the simplest explanation. But the truth is, this devastation of planet Earth was just beginning, and there were actually plenty of survivors to feel the effects long after the asteroid hit. One day after impact, any animals or plants who weren't wiped out in the initial blast of the asteroid or the subsequent effects of its impact felt around the globe weren't exactly what you would call lucky. Over the coming hours, days, or weeks, these creatures would face an altogether different kind of hell as the fallout from the asteroid continued to wreak havoc. Extinction wasn't instantaneous for every species, with many suffering a slow death of starvation and gradual ecological collapse. With wildfires still raging across the forested areas of the Earth, all of the resultant soot and smoke would be billowing upwards into the atmosphere, along with any residual smaller vaporized debris from the asteroid's impact. Once the debris reached the upper atmosphere, it spread rapidly across the globe, forming a thick sun-blocking shroud. Within hours, daylight vanished as the planet was plunged into darkness. And as you likely already know, plants die without sunlight. Now starved for the light that they require to photosynthesize, any plant life that survived the fires would start to die. Bad news for any of the literally thousands of dinosaur species who relied on plants as a food source. But it wasn't just the darkness and starvation that threatened survival. A haze of sulfuric acid filled the skies, sending temperatures crashing by over 70 degrees Fahrenheit within days of the impact. This would especially take a huge toll on any life at sea. The intense heat caused earlier by the impact may well have set off an ocean-wide crawfish broil, but the sudden drop would have just an adverse effect. Without sunlight and with temperatures lowered, the plankton population would have been all but decimated, with 90% of those microorganisms dying. Now, why does that matter? Well, they played an important role in the ecosystem, providing a food source for a significant portion of prehistoric marine life. Smaller fish eat plankton, bigger fish eat the smaller fish, and then small marine reptiles eat those fish, and so on and so on. Without that essential link at the bottom of the food chain, the larger marine reptiles and the ammonites, who used to be the ocean's top dogs, would also start to die out. Back on the land, most species were rapidly disappearing, as dinosaurs struggled to adapt to the radically altered biosphere of their home that had suddenly become uninhabitable to them. Herbivores that relied on plant life to sustain them were now finding themselves with little to eat, thanks to the denser areas of foliage being gone, reduced to ash. And the carnivore species that hunted the other dinos, well, they can't eat their fellow survivors forever, especially if they are dying out from starvation. It wasn't just the dinosaurs affected either. Any mammal larger than a rat would have been wiped out in a similar way, either killed in the asteroid's initial blast or suffering in its wake. Months after impact, Earth had become a truly hostile place. The skies were dark, temperatures had plummeted, acid rain poisoned water sources, and anything resembling fresh food was scarce and vanishing fast. Conditions above ground were a lot harsher, driving smaller mammals to burrow below ground in order to survive. Dinosaurs, though, they were in a bad way, but the asteroid wasn't solely to blame for that either. Even before the impact, Earth had been experiencing a period of climate change, one that already was making it harder for the dinosaurs to survive on the planet. The asteroid just took things up by several notches. For one, there had been significant volcanic eruptions disrupting large lava fields in the Indian subcontinent. Despite being unrelated to the asteroid, this volcanic activity would last for around 30,000 years, covering much of the surrounding subcontinent in boiling lava. The harmful gases that were spewed into the atmosphere had already been taking a significant toll on the Earth's climate, several thousand years after impact. By now, the dinosaurs were all but completely gone, though we'll talk more about how they technically managed to stick around in a moment. At this point, the world was populated mainly by the few mammal species that survived the asteroid's impact, most of them the size of raccoons. Luckily for them, vegetation returned to the Earth very quickly, as plant life had been able to weather the harsh conditions caused by the asteroid for a lot longer. However, after the dinosaurs' extinction, plant life primarily consisted of flowering plants and not a whole lot of actual sustenance for larger mammals. Any creatures that weighed more than 50 pounds would have quickly followed in the dinosaurs' giant footsteps. What was left were the basic animal groups that had been alive before the asteroid. Even though these mammals had suffered some level of extinction, enough had survived for their lines to continue. They still had to forage for scarce seeds and fruit-bearing plants that could serve as food. These placental mammals started to rapidly diversify, and despite the need to search for nutrition, they probably had an easier time of it now that there weren't any gigantic dinosaurs all over the place. 100,000 years after impact, eventually more surviving species began to emerge, those who were better adapted to the world's new environmental conditions. By now, twice as many mammal species were living in the forests, their foraging helping to bring the ecosystem back into working order. The dinosaurs weren't exactly gone for good either. Theropods, characterized by their hollow bones, continued to exist, or at least their direct descendants lived on. There's actually a small subset of these theropods still alive today. We just happen to call them birds. What happened next was a lot of evolutionary trial and error, especially for a number of the dinosaur lineages that became the birds. Birds were the first of the smaller-sized survivors that started to get bigger as they evolved. There were some short-lived groups of gigantic birds, some that were predatory and others that were herbivores, but they eventually also went extinct. 15 million years after impact. After all of the dinosaurs that didn't evolve into birds had died out, Earth hit a period known as the Oligocene epoch. This is when larger mammals started to appear and spread. But it would take some time for these creatures to even begin rivaling the immense scale of the dinosaurs that had once ruled the planet. The asteroid had acted like a reset button, and while mammals began to thrive, their size remained modest for millennia. By comparison, during the Oligocene epoch, the largest mammals were only about as big as rhinos, still far from dinosaur scale. Over time, though, the mammals and the birds steadily grew in size and dominance. The slow rise eventually paved the way for a new kind of mammal to emerge. Enter the human race. Except we had technically been here for a while. Primates didn't evolve after the asteroid impact, they were already here. In fact, they emerged just before the Cretaceous-Paleogene extinction event and somehow survived it. Alongside them were the early ancestors of rabbits and hares known as Lagomorpha and Carnivora, which were precursors to dogs and cats. That means that while there weren't exactly fully formed humans hanging out with the dinosaurs, the Flintstones style, our lineage does reach back to before the day that the dinosaurs died. 66 million years after impact. The age of the dinosaurs might have ended with a bang, followed by a slow and painful whimper. But it cleared the way for the precursors of many modern mammals, including humans, to inherit the world that was left behind. If that asteroid hadn't struck in the Yucatan Peninsula 66 million years ago, there is a high chance that we probably wouldn't exist. As for what comes next, well, that's anyone's guess. Modern humanity as we know it has only existed for 0.1% of the time that the dinosaurs were alive for. And while we might have done a lot in that time, from traversing space to splitting the atom, that doesn't mean we'll continue on forever. If there is anything we can take from the day the dinosaurs died, it's that any species' long-term survival is never a guarantee. Think the dinosaurs had it bad? See how humanity might spend its final hour in the last 60 minutes before asteroid impacts the Earth. Or click on this video instead.